Okay, so now we are looking at question 3. So we have question 3. Let's look at question 3. Okay, we have question 3. Find the volume of the triangular pyramid with the vertices A 222, B 433, C 454, and D 556. 3 points A minus 4, 5 are located in a rectangular coordinate system. Okay. And 3 point. Okay, I'm looking at find the vector projection on B. Okay, so the first one we start with A, only A. So A, we are just to find the volume of the triangular pyramid with the vertices A 222, B 433, C 454, and then D 556. So this question, we solved this in class, is the same question that we did, but I will just go over it very fast, so I will not spend much time on this that we have. So we have solution 3. Okay. Now with this question, we have to find the volume. So when it comes to the volume of a triangular pyramid, what that means that we write volume of triangular pyramid is going to be equals to, we take the volume of a parallel parapet, which is going to be this. So based on what we are given, we have to find the volume, and then because here, since we are given 4 coordinates, or you can say 4 points, right? We are given 4 points, and we want to find the volume of the parallel parapet, meaning we take what we need to get 3 kind of lines or dimension to get a volume. So that means what we are going to do is that what we tend to do, meaning we can write here to be, right? I can indicate here to be AB cross product of right? We can write AB cross product of what AC, then dot what AD. How do we then we do this? After that, we take the absolute value, then we divide this by 6, right? By 6. So these are distance vector. How do we come about this? It's just the idea that if I have point A here, then I have, let's say, point B, point C2 is here, right? And then maybe point D is here, right? So if we are interested in the volume of the parallel parapets, what that means that we can make sure that all this, they are going, maybe we have A, all these points are going to, maybe they are starting from what A, then they go here, this one to come here, right? So we have something of this. That means for when it comes to A, B here, they are going to form a plane, because we have cross product of what A, B, and then let's say AC. Okay, to rather this, right? This one here, they form this in a plane, and by doing so, okay, let me form the plane well. Let's form a kind of plane. form a plane like this, and we do the plane very well. So we have this plane here. Plane is somewhere here. Then once we have this plane which is formed, now we have our D, AD, then we do dot product of that. That's the idea. So based on this that I have done, I can write volume here, we use V1 will be equals to, like I just said, cross product of vector A, B, cross product of vector AC, distance vector AC, then dot of what, AD, right? Or you can make it the other way. You can make any of the coordinates, the point, the center, and then you get the same thing. Then we take absolute value of this over 6. Okay. Now that we've done this, let's get AB. When it comes to AB, it's just going to have vector B minus vector A, right? And looking at this, we have the coordinates that we are given. We are given for A from the question, we are given A to be equals to, the coordinates are 2, 2, 2. And then when it comes to B, the coordinates are giving us 4, 3, 3. And then C, we have 4, 5, 4, right? And then D, we have 5, 5, 6. So with this, I can get AB, and AB, what do I get? I mean, I'm just getting what, vector B, and vector B, we have 4 minus, so just 4 minus 2, which is what, 2 AS, right? Then I have 3 minus 2, meaning plus AY. Then we have 3 minus 2, meaning unit vector AC. So we have this. Then I can get AC as well. That means vector C minus vector A. And C is also here, meaning 4 minus 2. We have 2 along the x-axis. Then we have 5 minus 2, 3 along the y-axis. Then we have 4 minus 2, which is 2 along the z-axis. Then we can get AD. AD also this time with a D minus A. So that one too. I have D is here. 5 minus 2 will be what? 3 along the x-axis. 5 minus 2. 3 along the y-axis. And I have 6 minus 2, which is 4 along the z-axis. So we now have our distance vectors AB, AC, and AD. Now to get our volume, which is volume of pyramid, triangular pyramid, will be equals to, we put this in a matrix form, right? So we put the first one, which is the distance vector AB. So I have 2, 1, 1. I can put the unit vectors here. Right. Then we can add the positive and negative here. Positive and negative. So we have this. Then the next one is what? AC. This is that will be 2, 2, 3, 2. And then the last one we have 3, 3, 4. Right. Now we can, based on this, I can bring my 1 over 6 here, right? So that once you get the whole the whole matrix after that you divide by 6, and you get this straightforward. So with this, when you do all this, right, you do the first one. We are trying to find the determinant, so you cancel the first column, first line, then all that you get 12. When you cancel the second column, first line, you get minus 3. This one you get minus 3 as well. So we end up getting 7. That is the matrix of this. We get 7. Remember, over what? 6. Right. So over 6. So this is going to be equals to 7 over 6 cubic units. Okay. Now we are done with this one. Let's go to the next question. The next one is that's it. Okay, which is 3 points: A minus 4, 5 minus 1, B minus 2, 3, 1, C minus 3, 7 minus 6 are located in a rectangular coordinate system. Find the vector projection of A onto B. Okay, A onto B. So we are finding I. So when it comes to vector projection, right, we are projecting one vector onto the other. So we are projecting vector A. This is 3B I. I'm projecting vector A onto vector B. So I have vector A on vector B. So to do this, what does simply imagine I have my vector A. This is vector A here, and I have vector B, right? So what I mean, I'm projecting this onto this vector B. So I have my vector A. So to do that, what that simply means, it means that for me to project this onto the first, I have to know what vector A vector B. I have to know the unit vector of vector B, right? So the unit vector of vector B will be equals to, meaning the vector over its magnitude. So we get this. Right. Now that I've done this, I've gotten the unit vector. Now if I want to now do projection onto this, that means the vector projection here. First, we refer to this as a scalar projection. So first you do what we refer to scalar projection. What that means is that I have A, I'm projecting A onto what B, and I know the unit vector of vector B. So we can write here scalar projection of this will be what? A dot of what? Vector B. Okay. We get that one, right? So we get this vector A dot of this vector that I have here, right? So if you do the dot product, and looking at our question that we have, right, we go and look at the coordinate of what A is what, and then we look at the coordinates of B, right? Okay, so we have to find this. Let's start with when it comes to the coordinates of A, we have A being minus 4 from the question, 5 minus 1, and that of B from the question we are given minus 2, 3, 1. Now first let me get the unit vector of what? Unit vector of vector B, which is going to be equals to, meaning the vector of this is going to be what? Minus 2 along the x-axis plus 3 along the y-axis, then plus the unit vector along the z-axis all over the magnitude of this. That will be minus 2 square plus 3 square plus 1 square. This will just be the same as 1 over, right? 2 square will be 4. 4 plus 9, 13, meaning no, 4 plus 9 will be 13 plus 1, meaning root 14 here. So I get root 14. Then we have here minus 2 along the x-axis plus 3 along the y-axis, then plus along the z-axis. So I have this as my unit vector for this. Now I can even further simplify this so that we can just write 2 divided by root 14, or I can say minus 2 divided by root 114. That is going to get minus 0.535. Then we take this one, 3 divided by root 114. Plus 0.802 along the y-axis, then plus meaning 1 divided by square root 14. That will give us 0.267 along the z-axis. So I have this. Now that I've done this, the unit vector, now let's go and do the scalar projection. So I have vector A dot of the unit vector B will be equals to vector A, which is what? My vector A, or I can even write this as a vector form. This will be vector A is going to be equals to minus 4 along the x-axis plus 5 along the y-axis minus the unit vector along the z-axis dot of this, right? Minus 0.535 plus 0.802 plus 0.267. So now that we've done this, so the dot product of this will simply be, we do the dot product, and then what do we get, right? So with the dot product, when you do the dot product, meaning I'm going to have minus 4 times minus 0.535 plus 5 times 0.802 plus minus 1 times 0.267, right? So when you do all this, right, you get this thing to be 5.879, right? 5.879. This. So now that I've done my scalar projection, now let's go to the vector, the final projection, which is referred to as a vector projection. So when it comes to a vector projection, now I'm going to get my scalar, which is just what? Vector A dot product of unit vector B, now times again the unit vector. So I'm just going to have my scalar, which is 5.879, then times the unit vector, which is what? Minus 0.53, yeah, 535 plus 0.802, then plus 0.267. So we are going to end up getting minus 3.14 along the z-axis plus this times this, we get 4.715 along the y-axis. Then we multiply this 5.879 times 0.667, 1.569 along the letter. So we get this, right? This become our final answer with this. Now moving forward from the same question, still on question 3, right? So now our question 3. Okay, meaning II. Okay. So II, the distance from A to the midpoint joining BC, right? Joining BC. So meaning distance from A distance, II. So we have to find distance from A joining from A to the midpoint. The midpoint joining BC. So now to find our distance from A to the midpoint joining BC, first let's get the midpoint. We use M here, BC, to represent the midpoint of what? BC. So we know from the question, right? B, the coordinates are -2, 3, 1. And then C, the coordinates are given as -3, 7, -6. Now to find the midpoint just means that we are just going to take, like, we add the corresponding coordinate and divide by 2, right? So midpoint. Our right here, the midpoint will now be -2 plus -3 divided by 2. Then I have 3 plus 7 divided by 2. -6 plus 1 divided by 2. Right. So now midpoints are going to be here with -5, right? Divided by 2. That is going to be what? Right? What do I get? -2.5. In here with 10 divided by 2, that will be 5. Then we have -6 plus 1 -5. So here will be -2.5. So we have this. That's our midpoint. And we want to find the distance from A to this midpoint. So this now. So the distance we know from A to this midpoint will just be meaning starting from A. So I have distance vector, midpoint BC, which is going to what? The distance vector, the vector of my midpoint minus vector A. Now I have here to be my -2.5 minus vector A, and you know A here, the coordinates are, I have -4, meaning A -2 -4. And we have 5 minus 5, right? -5. And then just along Z. Okay. Along Z, we have 5 minus 5. Yeah. Then we have what? The next one, which is plus -2.5. And again A. The next coordinate, y coordinate of A is what? -1. So -1. Right. So I see -2 minus 2 minus 1, right? So minus 1. This becomes minus 2.7 minus 4. Oh, minus remember the code. Here will be what? Remember, here will be minus this minus 4. So here minus 2 plus 4. Minus 2.5 rather. 2.5 plus 4. 1.5 along the x-axis. Here will be 0. So you have plus. Here will be minus 2.5 plus 1. That means here becomes minus. So you get minus 1.5. Easy. So now that we want to find the distance, we'll take the magnitude of this. And then that will be 1.5 square plus 1.5 square. So what do I get in that case? Right. 1.5 square plus 1.5 square. And then we get 2.121, right? Units. So this is how we get this. Now that we've gotten this I, let's go to the next question, right? And the next question here, which is okay, this is supposed to what? There isn't a bi, but this is supposed to be, I think, bii. Yes, we bii. Okay. Determine the Laplacian of the scalar field W equals to RZ sine phi square, then plus Z square cos phi plus R raised to the power 3 at point P, where R is equals to 2, phi equals to 30 degrees, Z equals to 3. Right. Giving. Right. So here first we have to find the Laplacian of this. Now when it comes to finding the Laplacian, right? For Laplacian, we know Laplacian bii. Laplacian is what? The divergence of what? The gradient of a scalar field. So first, if I have a scalar field, and from here we are giving y, a w rather, which is the scalar field, and we have here to be r z sine square phi plus z square cos phi plus r. This is our scalar field. So first, what we can do based on the flow, first you find the gradient of the scalar field. Then after that, we take the divergence of the scalar field. So you can see that if you look at our scalar function, it's being expressed in the cylindrical coordinate system, right? Because we have what? R, phi, and then what? Z, right? So it's spherical. So we can get we now have to write the Laplacian formula when we are dealing with cylindrical coordinate system, right? So our scalar function expressed in cylindrical coordinate system, right? So we have to use the corresponding formula for calculating the Laplacian when our scalar function is being expressed in cylindrical coordinate system. So how do we go about doing it, right? So the way we go, if instead of memorizing the formula, one way that you can do this is by first, like I stated earlier on, you get the gradient. So if imagine we have this our gradient, and gradient here will be equals to, we know this, we get scalar del product on what a scalar function will be a vector. So I mean cylindrical, so we have AR plus, we differentiate the scalar function. Here we have R, define unit vector along the direction of the angle of rotation plus dw over dz, the unit vector on that. So we get something on this one. Now when it comes to now, after this is what we get. Now we take now the divergence of this scalar function that we have, right? The scalar divergence of the gradient of this scalar function. And we know that when it comes to divergence, right? So let's say I have divergence of what? A vector A is going to be equals to 1 over R, then R, AR, then R plus here A phi, R d phi plus AZ, then we differentiate with respect to what? Z. So this will be divergence of what? A vector. Now we look at this vector A to be the same as what? Our gradient, right? The gradient on the scalar function that we have. So I can write this. So imagine A is equals to what? This. That means AR here, I can replace this 1 over R, R dr, right? Then when I come here, my AR is this, so we can write differentiate this with respect to scalar function dr. Then when you come here, 1 over R, and differentiate this with respect to phi, and then I have my phi being this, right? R d phi, okay, then plus, and my AZ is what? With respect to this. So this becomes our Laplacian of this. Now we just have to do replacement with this. So now I'm just trying to now differentiate this function that we have. So in doing the differentiation, so first we know our R is this. Now we differentiate with respect to the first one, differentiating with respect to R, okay, and differentiating with respect to R. Yes, this is Z, okay. Now we know we differentiate with respect to R, so I get what? So here we are going to get the first one, which is 1 over R, and I have the R here. Now we put here into brackets, we differentiate the scalar function with respect to R. So if you do that, what do we get? For the first one, we are going to get Z So get z sine 2 phi. Okay, that's the first part. Then we go to the next. We have z squared cos phi. There's no r there, so with that place with 0. Here we have plus 3r squared. Okay, so this is what we get. Okay, this one. Now we go to this. Here r here, we can take r here outside, so that we have r squared. So I can bring my partial respect to phi here. Then first do this one, right? So we differentiate respect to phi. Here the first one we got is going to be, right, we are differentiating respect to phi. So what do we get? I have 2, right, to phi. We differentiate this respect to phi. What do we get? That means the first one we differentiate, so I have 2r sine, right? So we have 2r sine phi. That's what we did. And then now we differentiate, right, again. So we differentiate cos, no, we differentiate sine phi. Now sine phi will give us cos phi, so we have cos phi, right? Then after that we go to, still this continue from here. Okay, let me just cancel the whole of this so that we put this here. So I have here plus 1 over r squared. Then this respect to phi. So the first one we have rz 2 sine phi, right? Then after that we differentiate, get cos phi as well. Then we go to the next one, which is the next part, which is going to be z squared cos phi. We differentiate respect to cos phi, meaning we get minus sine z squared sine phi, right? Then here will be 0. So we get this. Then I can bring plus. So this one we are differentiating with respect to z first, the scalar function with respect to z. And when we do that, I'll get here to be r sine square phi. Then respect to z, we have 2z cos phi. Then here will be 0. So we have this here. Okay. Now that we've done, we now go and do the second differentiation, or the second derivative in a way. So again, we have our Laplacian being equals to, I'll bring 1 over r. This time we differentiate with respect to r again. You can see here there's no r, so here will be what, 0. And I'm just going to have only, right? So that part, I remember I have r, there's r squared here, right? I have r here, you multiply here by r. So when you multiply this r inside, so multiply here, so this become r, and here what, r is the power 3. So that now when we differentiate, I'll get this to be r to be just be z, yeah, to be 2 z sine 2 phi. Then this one will be what? Now be 9 square, right? We get this to be 9 r square. We get this. Smart. Okay. So this is this. Now let me bring the plus down here. So I know 1 over r square. We are doing this one differentiate with respect to phi. Differentiate with respect to phi. Here, cos we have cos phi, sine phi, and then cos phi. So if we differentiate, meaning with this we what product, right? So we differentiate respect to phi here. So if I'm differentiating, what do I get, right? What do I get in that case? Or what we can do, we can replace this, right? If we do replace this part, sine phi cos phi, right? It's going to be the same as what this is mathematics. Okay, if I have cos, cos phi, so if I have sine phi cos phi, right? We know that sine cos phi is, so how can we can find a way to replace this? Sine phi cos phi, we know that if I have sine a cos, rather cos A plus cos B, right, is going to be equals to, right? So one way, right, this one way we go about doing this part, right, is to simplify the sine phi cos phi, right? So if you have sine phi cos phi, what do we get sine phi cos phi to be? So if we have cos A plus cos B, is going to give us linear half cos A cos B minus sine A sine B, right? So we have this, right? Cos A cos B. So if we have this, then imagine I have cos. In that case, these are the same. So if you have cos here, cos in that case cos phi plus cos phi will be equals to what? Meaning 2 cos phi, right? Sorry, 2 phi. Cos 2 phi. And then here will now be cos 5 square minus sine 5 square, right? Now we sine 5 square. Okay. So if we have it this way, right? Or here, and so of course, maybe we rather use sine, right? No, let's try it. This one will not work. Let's try this. We could do this using differentiate using product idea, but I don't want to do it that way. Right. I don't want to spend on this a lot of time, but if I have sine A plus sine B, right? Sine A, sine B, right? We know this is going to be equals to, right? So I have sine A. If I have sine A, sine A so if I have sine A, right? Sine, if you have sine A plus sine B, right? Sine A plus sine B, what do we get? We get this to be what? Sine A cos what? B plus sine plus cos A, right? Right? Yeah, cos A. Plus is it cos A? Yeah, cos A sine B. Right. So we have this. So sine A cos B, you get something of this nature. So you can see that if I have sine A cos B and I want to try and simplify this, right? I can. So if sine A and B, they are the same thing, right? So I can write sine phi plus sine phi, meaning sine into 5 plus phi. So in this sine phi cos 5. So this now be twice, right, of this. So if you make it the subject, that means I can get sine phi cos phi will be equals to sine 2 phi divided by 2. So here, if we replace here, right? So meaning if I have this part here, we could replace the 2 sine 5 here by what? Sine A sine 2 phi. So I can remove this. So if we put here sine 2 phi, right? So that we can differentiate. If we are now differentiating, I know I'm differentiate inside. So here we have now this to be R Z. So you differentiate meaning 2. Then after that you take cos. So this now becomes 2 phi, right? Then I differentiate the other one, right? So we differentiate in respect to phi. This will now be what? Sine with cos, right? Because so here too is z square. Let me see. First one we differentiate, so it will be z square. So this will be z square. So if you differentiate this time, yeah, sine phi again, we get cos phi. So we have this. Then we now have plus. Here, this one we differentiate with respect to z. So the first part is 0. So we have 2 cos. simplify for this part. Okay. So now that we've done this, so this is our answer for this, and we are to find the scalar function at this point. So now that we have this, we can come and write the Laplacian at point P, and point P here we are told r is equals to 2, phi equals to 30, and then z equals to what, 3. So at this point our Laplacian is going to be equals to, but even before this we can further simplify, right? Simplify this because I have r, meaning I can, or we can even just make the r outside, right? Yeah, you can just even leave it. Okay, let me just leave this. Okay, maybe r here it's good to simplify because I have r. Even with this one too, let me leave it. So you just come and replace. I have 1 over 2. So there's 2. Z is what, 3. Sine this 5, which is 60 degrees, or 30 rather. 30. Then we have the next one, which is plus 9, 2 square, right? Then plus 1 over r square, meaning 2 square, into brackets 2r z, which is what, 3 cos 60 minus 3 square cos 30 plus z, right? No, it's rather 2 cos 30. So when you do all this, you get the answer to equals to 19.658. Okay. This is our question. Now you have to find, given this, find the divergence of this, right? Now the second part of the question, wow. Now the last part, which is here, find the one, given the divergence, given the electric flux density, R is equals cos square phi on the z axis, find the divergence. So you can see this one is given in, again, we are dealing with what, cylindrical coordinates, right? Because we are giving z, we are giving I. We are giving I4. This is RZ cos square phi along the z axis. We have to find the divergence d, and this is expressed in cylindrical coordinate system. We know divergence will be equals to 1 over r differentiate respect to r. Then we have the d phi respect to r, d phi plus dz, then differentiate respect to dz. So we have this. Based on this question, you can see we have what, we don't have dr, d5. So they are 0. So this will be 0. Then we are just differentiating with respect to z. So I have here to be r cos 2 phi. So this becomes our r cos 2 phi, which is our answer here, r cos square phi rather. Okay, so we have come to the end of question 3. Okay, so I'll try and solve the last year's final examination, so watch out for that one. Bye bye.